Therapeutic hypothermia can either be delivered locally or systemically. In local therapeutic hypothermia, only a certain section of the body is cooled versus systemic hypothermia, which involves cooling of the core temperature of the whole body. In recent years, systemic hypothermia has been implemented more than local hypothermia. The first is slowing the rate of metabolism of neurons after a SCI, which inhibits the generation of lactate, hydrogen, and phosphate, as well as preserving glucose. The second is a decrease in the generation of free radicals through inhibition of lipid membrane perioxidation.
Another proposed action is decreasing excitotoxicity by decreasing the release of excitatory neurotransmitters such as glutamate. Hypothermia is also suggested to work by antagonizing apoptotic signaling within neurons and glial cells following an SCI, as well as dampening the inflammatory response by reducing microglia activation.
Another neuroprotective effect of hypothermia is the preservation of the blood-spinal cord barrier integrity, thus preventing edema. Hypothermia has also been shown to retard osteogliosis and scar formation, while aiding neural repair by expressing pro-angiogenic factors and promoting neurogenesis.
Is there any evidence for the therapeutic benefit of systemic hypothermia? The earliest report of beneficial effects of systemic hypothermia following an SCI was by Van Herreveld and Tyler in 1944, who observed reduced tissue damage and better functional outcomes in SCI animals following hypothermic treatment. Then, in 2000, Yu and colleagues reported that moderate systemic hypothermia initiated within 30 minutes after an SCI in rats had neuroprotective effects up to 44 days post-injury. This was demonstrated by improvements in locomotion and a reduction in tissue damage.
Since then, there has been more studies on systemic hypothermia for acute SCI on humans. The Levi and colleagues' 2010 study found that within 1 year of being treated with systemic hypothermia, 6 out of 14 complete SCI patients improved to incomplete injury. This study was the first modern-day case series to showcase the effectiveness of systemic hypothermia for SCI. Similarly, in 2013, Didsey and colleagues came to a similar outcome with 15 out of 35 SCI patients improving within a year after hypothermia administration. In a 2015 study, rats with T9 SCI subjected to modest systemic hypothermia exhibited motor and functional recovery as well as positive effects on inflammatory and apoptotic pathways.